In this part of our training, we will discuss multicells, clusters, and squall lines. Multicell cluster storms are the most common type of thunderstorm we have here in Illinois. They produce moderate to strong updrafts and weak to moderate shear. They form near fronts and boundaries from nearby storms. They can produce heavy rain and hail, as well as downburst winds and weak tornadoes. In this picture, we can see several multicell thunderstorms off in the distance. Storm A is currently the most dominant storm, whereas Storm B and Storm C are still building. A short time later, Storm A has begun to weaken, and Storm C has taken over as the dominant storm. Storm C remains in development. A short time after that, Storm B has met the same fate as Storm A, whereas Storm C has now become the dominant storm. And further down the line, we can see that Storm D and Storm E are also in development. Approximately 40 minutes have elapsed between the first picture and the last. New storms will usually form on the west or southwest side of the cluster, and dissipating storms will weaken on the east or northeast side. These clusters typically last about an hour or two. This is how multicell storms appear on radar. Similar to the previous images, the weakening thunderstorms are currently on the right side of this line in the radar image, and the strongest thunderstorm has taken over further to the west. Even further west from there, we have a new developing thunderstorm as well. A squall line is a long line of separate storms that usually develop ahead of a cold front. They contain moderate to strong updrafts and moderate to strong wind shear. Squall lines are usually oriented in a north-south or northeast-southwest direction. Multiple downdrafts will merge to produce a gust front. With squall lines, you have the potential for high winds and damage, along with occasional tornadoes, heavy rain, and hail up to golf ball size. When you are spotting, look for a shelf cloud at the front of the squall line. This will be a low cloud that appears. This is where the warm updraft and the cool downdraft meet. Shelf clouds that are low-hanging with a wavy look, such as this area in the top right part of the picture, often produce the highest winds. Shelf clouds can occur in severe and non-severe storms. With a severe storm, look for a well-defined leading edge with a deep shelf cloud, similar to the picture we see here. They also have wavy, turbulent clouds, similar to what we saw in the previous picture. Here's another example of a well-defined shelf cloud. Each of these storms produce wind gusts of 60 to 70 miles per hour, as well as damage to trees and power lines. In a non-severe storm, the shelf cloud is much more shallow and appears to have any lack of structure. In these two cases, both storms produce wind gusts of 35 to 40 miles per hour. Looking at a squall line on a radar, here from April 19th of 2011, we see a significant squall line that starts at least in east central Indiana and goes all the way down into eastern Arkansas. When you are looking at this type of radar image, tornadoes will be most favored in areas where there are kinks in the line, such as here in eastern Arkansas, as well as in southeast Missouri, and near the Illinois-Indiana border northwest of Evansville, Indiana. Tornadoes are also favored where there is an end or a break in the line. High winds can occur anywhere along the leading edge of the line, but are most prominent in areas where the line is curved. In these particular examples, wind gusts of 70 to 100 miles per hour occurred along the Ohio River west of Evansville, Indiana, and wind gusts of 70 to 85 miles per hour also occurred around Indianapolis. These curved parts of the line are referred to as bow echoes. It is a bow-shaped line of radar returns often associated with intense straight-line wind damage and occasionally tornadoes. When looking at radar for a bow echo, note the sharp curvature in the rainfall image. The heavy rain and high wind will occur at the very front of the storm. Often bow echoes will have a comma head on the north end of the bow echo. Also note that there will be an area of weak reflectivity punching in upstream of the highest winds. When you're out in the field, while you will notice a shelf cloud with such a feature approaching, there is no way to really determine that it is a bow echo unless you are looking at radar. Here's another example of a squall line on radar. This one again goes from central Indiana down to at least into southern Missouri. While this does look like it's the most significant feature, we also have to keep an eye on these isolated storms that are forming ahead of the line in southeast Missouri and far southern Illinois. Oftentimes these storms can become severe or even tornadic. They often have the potential to become supercells as well.